Two motor proteins walk into a bar. One says, "I'm Mousin, you?" And the other replies, "I'm dying, and my job is to transport items from the ER. I wonder why haven't I been treated yet? I'll show myself out." Scientists recently discovered how large lipids and proteins move between the endoplasmic reticulum and the Golgi body. They are transported in vesicles with protein coats between the rough ER, where they are synthesized, and the Golgi body, where they are packaged. The protein coat of the vesicle going from the Golgi body to the ER is named COPI, and the one that involves substances moving from the ER to the Golgi body is named COPII. Let's take COPII as an example. First, a protein called SEC12, which is a guanine nucleotide exchange factor, attaches to the area which will become the vesicle. This attracts an inactive protein known as SAR1 GDP, which is then activated and becomes SAR1 GTP. SAR1 is responsible for many different things, such as protein coat recruitment, cargo management, etc. The SAR1 will start recruiting proteins, with SEC23 and SEC24 forming the first protein layer, which is needed for the vesicle to start the budding process and is involved in the binding of cargo molecules. Then recruits SEC13 and 31, thus forming a cage-like second layer, which is called polymerization. Some long molecules like collagen cannot fit into a canonical vesicle, and thus two proteins by the name of TANGO1 and CTAG5 can distort the vesicle to fit many materials. Then, the membrane will undergo scission, which is also thought to be driven by SAR1. After the vesicle has detached from the ER membrane, SAR1 GTP will convert itself into SAR1 GDP, resulting in the disintegration of the protein coat. A motor protein theorized to be dying will bind onto the vesicle, which moves the vesicle along a microfilament towards the Golgi body. COP1 is the name of the protein coat that coats vesicles traveling between the Golgi body lobes and from the cis phase of the Golgi body back to the ER. ARF1 GDP, which is inactive, will be activated and become ARF1 GTP. Then, it will recruit proteins referred as alpha, beta, beta prime, gamma, delta, epsilon, and zeta. These proteins will form a coatomer, which will form the protein coat itself. After polymerization, the vesicle will break off into the cis phase of the Golgi body and travel to the ER on a motor protein. What happens when these systems malfunction? A syndrome known as craniolenticulosutural dysplasia is caused by a mutation in the SEC23 protein that causes SEC13-31 to uncouple from the vesicle. This will cause fibroblasts to have dilated endoplasmic reticulum as collagen DPY7 cannot be secreted, thus causing skeletal defects. These processes have far-reaching implications in the field of medicine and pharmacology, and is generally important in the giant scheme of life. Who could imagine that life as we know it are powered by these small, lifeless machines?